Hi, I'm Taylor Eccleston, and today I'll be teaching you a lesson on average rates of change. So, in this presentation, we're going to have an overview at the beginning, covering the lesson. Then we're going to learn about the formula. Then we're going to have a graphing method of average rate of change, example of this graphing method, and then we're going to have a conclusion about the graphing method. And then we're going to look at an algebraic method, an example of one, a table of values method, and an example of one of those as well. And then we're going to wrap up the lesson with a few key things that we need to take away. So as you may know, AROC stands for average rate of change, and we will be using that abbreviation in this presentation. Rates of change involves a measurement of how fast something changes, or the rate that something is changing at. By simply looking at a graph of a certain function, the rate of change is a measure of how steep the slope of the line is, in which we call the secant for average rates of change. In different situations, we can measure the rate of change over two specific points, which is average rate of change, or we can measure the rate of change at a specific point on the graph, which is instantaneous rate of change, which we would call IROC. However, in this lesson, we will be covering all of the three ways that you can measure AROC. I have laid out three examples that represent methods that you can use to either find the IROC and the AROC. However, in this lesson, we will learn how to do one, which is AROC, as mentioned previously. Meaning, we will learn how to find the rate of change at a given interval or domain, no matter what the form the function is in, whether it be graph, algebraic, or table values. So first of all, you want to know the formula. So, as we can see here, m equals rise over run, which turns into the change in y values divided by the change in x values of two specific points. As we are given the intervals when measuring average rate of change, we can subtract the two intervals here, the second interval being first, and the first interval being second. And, depending on the type of question it is, whether it be graph, table values, or algebraic, we can somehow get these y values from that information. In official terms, we can look over here and see that f of x2, which is y2, minus f of x1, which is y1, divided by x2 minus x1. We need to figure out how to solve when given a graph in where we can see the values. The intervals given to you in the question create something called a secant line. A secant line is basically the 2 points and where you're measuring the average rate of change from. For example, on the right hand side here, the secant line has 2 points, which are the x intervals when given the question. These are the 2 points that you're measuring the average rate of change from. In this case, you can then draw a secant line straight through. The slope of this line represents the average rate of change, in which you will find when you complete the formula. To break any confusion here, the secant line is not the same as a tangent line. The tangent line is for measuring instantaneous rates of change. However, there is confusion on this topic due to the fact that the slope of the tangent line is the measure for instantaneous rate of change, and where this point is directly on the graph right here, but we don't need to concern ourselves with that. One example of the secant line is both here and here. We've already covered that. So, first we will find out how we can determine the average rate of change using the graph and the specific values on the x-axis. In this case, it's going to be -3 and 3. By seeing that the value on the left-hand side, which is -3 right here, is 2.5, and that the value on the right-hand side, which is 7 on the y-axis, we can begin to plug it into a formula that we are given below. The change in units vertically versus the change in units horizontally. We can then see, using this formula described earlier, that the average rate of change for the intervals x equals -3 and 3, in the graphing example, we don't have to plug in the intervals because we already have the value on the graph right here. We can just visualize it. So when we go to -3, we can immediately see that it's 2.5, and then when we go all the way up here to 3, we can see that the value there is 7. So solving the formula would mean that you would need to find the change in the y values over the interval -3 and 3. And you would then divide the difference in y values by the difference in x values. So the solution is here that you get 7 minus 2.5 due to having these two y values here, and then you divide them by how many units you've traveled, and that's how you get the average. So we're going to do 7, which is our second y value, minus 2.5, our first y value, and then we're going to divide that by we have our second interval here, 3, and then we have our first interval here, -3. So when you subtract these, it ends up being 4.5 divided by 6, which is 3/4, or 3/4, whatever you want to call it. For more simple terms, for you to understand better, we can also say that the output goes up 3/4 of a unit per 1 unit across. The average rate of change answer doesn't necessarily look like it's supposed to in this graph, if it is supposed to look like anything. However, the line shown in the visual representation, which is the secant, gives us a good idea of how the values had increased over the given intervals. However, it has also decreased. Okay, so in conclusion, the AROC is 3/4. So, the graphs are pretty easy to visualize, and they usually help you visualize what you're measuring. And they personally help me with visualizing what I'm measuring. Especially looking at the slope of the secant, we can kind of check our answer, seeing how steep it is. If the slope that you get doesn't line up with what the line looks like, then maybe you made an error along the way. As well, if you know the coordinates on the graph, either that or it comes with a regular function, but if you know the coordinates on the graph, you can easily subtract your second y value with your first y value as you have the numbers right in front of you. We can also visualize what intervals that it's covering, and if it's a word problem, drawing a graph will really help with understanding the reality and what is actually going on. I will now go over the steps that you will need to take if you are given a function like this one right here, f of x equals x squared plus 5x plus 10. So, first, you want to plug y2 into the function and place it into the formula. This means take your second x interval and plug it in right here, which means you solve the function by plugging it in all the x's, and then you find the value, and you place it on the top left. Then you're going to do the same for y1. Just plug it into the function, find the value, place it up there. Then you're going to go ahead and divide those values by the intervals. The second interval subtracted by the first interval. Pretty simple. Once the values are placed into the formula, you can complete it by subtracting y2 minus y1. We already went over the formula. Once the values are placed in the formula, you can complete it by subtracting the top and bottom values and then dividing them. Then, when you get your answer, always remember to use units so that you don't lose any marks within your answer. Okay, For an example of an algebraic question that you could be given to find the average rate of change, we are going to be using the example right here, f of x equals square root of x plus 4. So first, by plugging the intervals into the function, we will determine the rate of change over the interval -3 and 5. For the function f of x equals square root of x plus 4. In order to solve this, we just plug the intervals into the formula and then we get our answer as described in the previous slide. Just by looking at the intervals, we can then go ahead and do the calculation. Using the second interval, which is 5, and plugging into the function gave us 3. And then using the first interval, which is -3, and plugging into the function gave us 1. Right here. And then we're going to divide that by 8, because get rid of the negative signs here, 5 plus 3 is 8. Okay, so then you subtract 3 minus 1 divided by 8, and then 2 divided by 8, and then you can simplify that to 1 divided by 4. Always remember that if you are asked multiple questions with the same interval, you can use the same denominator for each question, and it will spare you the subtracting of the two intervals here on the bottom. Remember that for the evaluation. Okay, so a table of values is an excellent way to understand average rate of change because the y values are previously calculated for you, unlike the graph. And it is a very accessible way to calculate multiple average rates of changes at multiple points. However, even though a table of values will be very useful if you have it, creating a table of values will take much longer than finding the average rate of change by using a graph or algebra. So, a value. When you're creating a table of values, you need a formula. If you are given a formula, you may want to use the table of values, even though it's a little bit of extensive work. It will help you find the values right away if you're making multiple calculations with multiple intervals. The average rate of change formula is used so that you don't need to run values through a function and get a table of values, especially when measuring the average rate of change between two values that are on the same table of value. If you do not have a function or a graph, you cannot create a table of values as previously mentioned. Moving into a table of values question, we're going to be using the intervals -2 and 2 as laid out right here. The function that we're going to be using is -2x. However, when we have a table of values that contain the intervals that we want to measure, like we have in this example, like here, -2 and 2, then we do not need to use the function to plug the x values into. So we will now look at the example of the question and where you can find the average rate of change over this interval. Without using the formula, we can simply subtract the second y value, which is -4, by the first y value, which was 4, and divide that by the second interval given, 2, subtracted by the first interval given, -2. When we subtract -4 by 4, we get -8, and then when we cross out the negative here, we get 4, so it would be -8 divided by 4. The resolution that we come to is that the average rate of change for this graph right here is -2. The reason as to why it's negative is due to the fact that the average rate of change is decreasing over the graph. As you can see, the graph is negative. To visualize it further, we can also see that the function is negative. You should notice by looking at the graph that the answer is negative due to the fact that the average rate of change is decreasing, and it makes sense in real life too. Okay, you need to know the formula and you need to memorize it. And you need to relieve yourself of the confusion by remembering that the second y value is subtracted by the first y value. And with the x values laid out in the intervals, you subtract the second x value by the first. And you do not want to get mixed up with double negatives. You want to also know the secant versus tangent. It can be confusing sometimes, learning both at the same time. You have to remember it this way. The secant line is the average rate of change, and the tangent line is the instantaneous rate of change. The tangent line has 1 point, and the secant line has 2. You need to visualize what you're measuring as well. When you're looking at a graph, it's easy to visualize what you're measuring, and it's easy to check your answer when you have a graph. So now we know how to find average rate of change when we're given a graph, as we can use the values straight from the graph to just throw them into y2 minus y1 divided by x2 minus x1, which is great. We can then find the average rate of change when given a function by plugging the intervals into the function, and the result being by plugging the second y value into the function, placing the result up, and then subtracting that result by what the result of the first y value going through the function. We also learned how to find average rate of change when given a set table of values, and we learned that a table of values is unnecessary in certain situations. However, a table of values is very convenient when measuring values that are next to each other that have a 1 unit difference. The table of values is also similar to the graph in the sense that it places the values in front of you and helps you visualize what numbers you're measuring. Thank you for listening. The assessment will test your skills on average rate of change, and attached with the assessment is also certain questions on instantaneous rates of change and certain things above and beyond that is still achievable for certain scholars like you. Are you up for the task? Thank you.